Welcome to this information session on emerging semiconductor and quantum technology components, which is one of the accelerator challenges that we have in the European Innovation Council work program. My name is Annemarie Sassen and I'm the head of unit of the Program Manager's Office of the European Innovation Council. And in this session, I'm here with Samira Nick, the Program Manager for Quantum Technology and CHIPS Act. So in the next 2 hours, what Samira will do is explain you all about this accelerator challenge, emerging semiconductor or quantum technology components. And you have the opportunity to ask questions to her. In order to do that, you should use Slido. So you should log in, sly.do or connect. You don't need to log in. You should connect to Slido.do and use the event code challenges. So after then the explanation of Samira, she will also answer all your questions that you have. So if we look again at the agenda, Samira. So we will have the explanation of the challenge, which consists of 2 components. One is based on, or it's dedicated to quantum technology components. That's part A. And part B is dedicated to semiconductor chip development. So Samira will explain the whole challenge around these 2 topics. And then around 3:10, she will answer your questions that you have put into the Slido. What I want to say is that this information session is focused on the quantum technologies and semiconductor components. If you have more general questions about how to submit an accelerator proposal, for instance, for that I would like to refer you to an information day which has been held before on the 13th of December, where the more general scheme is explained, but this is really dedicated to this topic. So I want to start with a short introduction, what the European Innovation Council is. And on this slide, you can see that it's part of Pillar 3 of Horizon Europe. And this pillar is called Innovative Europe. And the European Innovation Council has been set up to address the problem that Europe has, that it does a lot of good research, but it's not brought enough to the market. We don't see the companies corresponding to this good base of research. And that is exactly the purpose of the European Innovation Council, to promote good research and bring it to the market as soon as possible. And in order to do that, the European Innovation Council has some other instruments than the rest of Horizon Europe. The total budget for the European Innovation Council is around 10 billion euro for 7 years, and that's about 10% of the whole of Horizon Europe. So if we go to the next slide. The 3 instruments that we have in the EIC is Pathfinder, Transition and Accelerator. And with Pathfinder, we focus on early stage technology research, so very low TRL, but research that really has potential for creating breakthrough innovations. The financial instrument used there is a grant and can be up to 4 million euro. If a project has successfully completed Pathfinder, or has done, if there's another project in Horizon Europe somewhere else, but you have this proof of concept, you have technology which is at TRL level 4, around that, but not yet ready for the market. It still needs more maturation. It needs more thinking about the market that it could address. Then our second instrument is EIC Transition. And in Transition, you will also get a grant, and it's really for further technology validation. Our largest instrument in financial size, it's the EIC Accelerator. And there it is for higher TRLs, and it is for commercialization and scale up. So here, SMEs or startups, they are the main beneficiary. They can apply a loan. There is a grant part up to 2.5 million euro, but there's also equity investments up to 15 million euro and sometimes even more. And this larger financial ticket size makes it the right instrument for scale ups, and it can overcome funding gaps that are existing at the moment to really develop these new breakthrough innovations. So if we go to the next slide. So I explained that our 3 instruments, they, with each of them, you reach a higher technology readiness level, but you also have to think about the business readiness level. And also that goes up if you move from Pathfinder to transition to Accelerator. So in Pathfinder, which is still early research, you start with the question, what can my technology do for me? How can I make the technology such that it delivers on the potential? So it's then you end up with a proof of concept. Whereas when you are in the accelerator side and you're thinking more about the business, your main question is why? Why would customers buy my product? What is my unique selling proposition? What should I do to satisfy better customer needs? So you have a different question there. And this is just to show you that it's really the intention of the EIC to accompany the beneficiaries on their entrepreneurial journey with increasing readiness levels. So if we can go to the next one. We do not only provide financial support, but we also have other services. And a big part of those services are business acceleration services. You can see some of them on the left-hand side of this slide. For instance, we provide access to entrepreneurs, to all our beneficiaries. And that means that we organize dedicated events where investors can meet the companies that they would be interested in. Or as a project, you can get a mentor, a person who is experienced in developing business, who can guide you individually in all the steps that you need to take to become an entrepreneur. We also have, as part of building up ecosystems, we have days where we call them corporate days, where corporate is meeting several of our beneficiaries who are in their domain of interest. And this, they're the SMEs, the beneficiaries of us, they would pitch to this corporate in the hope that this will lead to sustainable relationships afterwards, and that the corporate and the startup can team up and develop business together in the future. So we have many of those services, but we also have something else which is unique to the EIC, and that are the program managers. So we have 10 program managers, and on the right-hand side you can see the specializations of the program managers that we have. And you see there is one on quantum and electronics, which is Samira, who will present in a minute to you her challenges. So the program managers, they are hired for 4 years by the European Commission, and they are experts in their field, and they have research knowledge, but also they have experience in bringing this knowledge to the market. So they also know about innovation. So they have unique, let's say, expertise, and they are there to help the projects further. And in their daily job, they do 2 things. One is to develop a vision around what is an area where at the moment Europe is underinvesting, even though we have a lot of potential, but we don't have yet enough companies. So what are these areas in which we should invest more? And they translate to the challenges that we have in the work program. And the second thing that they do, once projects are selected according to these challenges, they work with these projects and support them to really make it to the market. And for instance, If several projects are facing certain barriers, they all have the same barriers which hamper their innovation potential, for instance. With the program manager, they can tackle those barriers together so that hopefully at the end of the project, they can go to the market. So if we go to the next slide. On this slide, you can see the whole work program of the EIC. So this year, in 2023, we have 1.6 billion euro available. You see the three instruments, Pathfinder, Transition, and Accelerator. And each of these three instruments, they always have an open part. About 50% of their budget is dedicated to open. And in open, it means you can propose a proposal on any topic which is related to deep tech and highly disruptive innovations. And half of it is related to the challenges, which are designed by the different program managers. So you see that for the three instruments. And also in Accelerator, we have challenges and an open part. And actually, this year is the first year we have so many very focused challenges in Accelerator. On the right-hand side of the slide, you can see all the challenges that we have. Today we will then discuss the ones on the Accelerator, fault-tolerant quantum computers, and semiconductor chip design. But we have organized information days on all of these challenges. Many have already been taken place, but we are recording them so that if you would be interested in any of the other topics, you can always watch the recording of any other of these information days that we organized. The next slide, please. Yes, this is just an overview of the cut-off dates of the various calls. So in this case, we are now in the Accelerator topic. We are in a challenge of Accelerator. And you can see that you have 3 dates before which you can apply to the call. 22nd of March, 7th of June, and the 4th of October. So also this is very flexible, and it's the idea to provide support to the companies when they need it. So with this, I want to hand over to Samira, who will explain you everything about the Accelerator topic on semiconductors and quantum technology.
Thanks a lot, Anne-Marie. Hi, everyone, and welcome to this session. You already know me. I'm Samira Nick, Program Manager for Quantum Tech and Electronics, and I would gladly explain the challenge that we have this year in the EIC work program for quantum and semiconductors. I would just like to highlight that you can use these links for having more background about EIC work program, where you can find a lot of details, and also the recording that Anne-Marie mentioned for the info day that explains the general frame of these challenges and how you can apply. That was recorded on the 13th of December. So let's start by talking and explaining these topics that we have for this year. I would like to just follow up on what Anne-Marie mentioned. I would like to just highlight some points about the need of really supporting innovation in Europe. And in EIC, we really try to help startups and SMEs and spin-offs to reach the market and scale up, because we think there is a gap and there is a holding back for European innovation. Why? Because innovation performance is lacking, because there is strong research is happening in everything in Europe. Europe is quite a leading partner in many fields of research, but they are not translated into innovation. And there is lack of breakthrough disruptive innovation that can create new markets. This is what we see in other parts of the globe. Then the funding of innovation, the innovators in Europe are having these difficulties to get finances, and they are facing 2 valleys of death. The first one is for transition from lab to enterprise, and the other one is the scaling up for high-risk innovation startups. And also the innovation ecosystem in Europe. Just a good example is actually quantum. There are many national initiatives, there are local ecosystems, but if we look at the whole European ecosystem, there is a lot of fragmentation. So we really have to make our goals aligned to make sure that we are using these resources in the best possible way. Another one is that we have to make sure that we include all regions in Europe, also widening countries, and also female entrepreneurs and researchers that should have a more prominent role in this world of innovation. Just to let you know about a little bit of the statistics that why we say we are lagging behind, because if you compare, like for instance, the innovation, the investment that is happening in innovation in US and in Europe, you can see that it's 4 to 5 times higher in US, and it actually in the last, let's say 10 years, the gap has been bigger and bigger. So this is why we are trying to really focus on help the European startups on different fields. And for my field, that is quantum and electronics, I would like to introduce you briefly to what we already have. So we have a large number of projects that has been inherited from the FET Open program, and also some of the projects that we already have that are from the open scheme that Anne-Marie just explained. So in the Pathfinder, we have a lot of projects that are covering all areas of quantum computer, simulation, communication, sensor, and also enabling technologies. For transition, we are more focused on computers, sensors, and communication. And in Accelerator, you see again that we have a focus on all of them. We have a very outstanding startups in all fields, but quantum computers are a bit higher in number. There is another point that I have to highlight, because this challenge is directly linked to the European Chips Act. As you know, the European Chips Act is addressing the semiconductor shortage, and it's for strengthening Europe's technological leadership in semiconductors, and which is applied in many other areas and industrial sectors. The whole budget is 43 billion euros. It is not yet adopted. However, EIC has a mandate to spend 300 million euros and contribute to the goals of the European Chips Act. And this is why we dedicated 100 million euros of that to this topic, 2 topics, let's say, quantum and semiconductor chip design for this work program. So let's start to dig into this challenge. Before that, I would just like to tell you that the goal of this session is mainly providing a background and the challenge, and explain as it is written and presented in the work program. And I will answer your questions about this challenge, but please be aware that this is not a session to give feedback of appropriateness of your individual proposals. This is not a place to do that. Also, again, if you would like to have a little bit better understanding of the legal basis and how you can apply and what are the criteria, please check the work program. So as an overview, let's start with the important message that I just explained, that this challenge is contributing to the Chips Act, and how it's by supporting the development of critical technologies where startups and SMEs in Europe will have an opportunity to bring their disruptive innovations to the market and scale it up. And in this way, they will help the strategic autonomy of the European Union. Because this is a very critical topic for Europe, and we have been exposed to a lot of shortages. Another point that I would like to highlight is the specific conditions. So the applications for this accelerator challenge can get, because it's an accelerator instrument, they can get an investment component of up to 15 million euros or above, if eligible. And they also have to make sure that the technologies of the strategic nature for open autonomy should not be directly or indirectly controlled by third countries that are not associated to Horizon Europe, or by legal entities that are not associated to Horizon Europe. And it's very important that these challenges will develop in robust manner and paying a specific attention to safety, security, and ethics, because these topics are very important and strategic. So as I explained, the budget is 100 million euros. I just want to explain how it's divided between these two topics. So it's decided that at least 30% of this budget will be allocated to quantum technologies components, and at least 30% to semiconductor chip development areas. And the remaining will be flexibly allocated to the to each of these areas based on the successful submissions of the proposals. So let's talk about the quantum technology component part, which is part A of this challenge. As you know, there has been a global search for quantum technologies in the past 2 decades. Let's say it has been there have been a lot of activities and initiatives, and a lot of startups have been established globally and also in Europe. However, still we have problem for scaling up large-scale quantum computers, and it's remaining a challenge. But as you can see, we have already a lot of outstanding European startups in different fields. So let me give you an overview. If we look at 42 countries and the startups that were established in the last 10 years, you can see 441 startups globally established in the area of quantum. 50% of them are located in US, Canada, and UK. So the other 50 is shared between Europe and the rest of the world. And it covers all different parts of quantum ecosystem. So this is the European landscape. In the international quantum startup landscape, Europe has 121 startups, which is a good number. But we would like to go through the things that are not really supported or they have difficulties. So based on this, just to let you know why we focus on the topics that I'm going to explain, based on the information and identification of shortages and potentials that we see in the European quantum ecosystem, and also by aligning with the European quantum flagship to make sure that we are not overlapping in financing the same topics. And at the same time, we would like to have complementary technologies that help the final goals of the European quantum flagship. We do a lot of studies on the new trends, the topics that are most promising. We discuss with scientists, we collaborate with scientists and ask them to send us their ideas. We have workshop and discuss, and finally we come up with ideas what should we focus on. And for this year, for this work program, we focused on quantum technology components that I will explain. There are 3 areas that we are focusing. And this is very important and strategic because there is a big race on quantum development, and Europe is leading the research, but still is lacking behind the innovation part of it and bringing this to the market or to scaling it up. So therefore, we are focusing in this challenge to support groundbreaking innovation that can have a high potential to develop these areas. The first one is fault-tolerant quantum computing. You know that quantum computers has already attracted a lot of investment. There are a lot of governmental and national schemes for funding quantum computers. Also, there are a lot of private venture capitalists that are doing that. But at the same time, quantum computer hardware is still suffering, and because of large errors that are happening during computation. And none of the solutions that are presented today are close to come to the need of a good control system to scale up, and also to have thousands of qubits that can run with a good low noise and good alignment with the different parts of the control systems. So why is it important to focus on this topic? Because quantum computers has applications in many different fields and areas, which are important, and they are going to shape our future. Quantum computers will be used in artificial intelligence, machine learning, in computational chemistry, drug design and development, cybersecurity, cyber cryptography, financial modeling, logistics optimization, climate change, and so on. So this is an important topic to focus on. And if we look again to the European landscape, we will see that the quantum computing hardware, the share of Europe is still less than US, UK, Australia, and the rest of the world. And we know by the discussions that we had that our startups need more support in that. This is why in this topic, we specifically focus on improved performance of quantum computers, significantly simplified quantum processing units integrated with control electronics, and scalable control systems, scalable to tens of thousands of qubits that are needed for meaningful practical applications. I hope this is clear. So let's move to the other part that this part of the challenge is focusing on. The second one is quantum sensing components for real environment application. As you know, quantum sensors are using for measuring different physical properties, including temperature, magnetic field, rotation, and so on, and with extreme sensitivity. And there are two generations of quantum sensors. The first one includes devices such as microwave atomic clocks, superconducting qubit interfaces. And the second one includes gravity sensors, nitrogen vacancy sensors, and other innovations. They have a lot of applications in many different fields, and they're going to improve the way that we do our metrology and measurements. For instance, they can help us having faster and more accurate and more reliable geolocation devices. Also have more accurate medical diagnostic imaging systems with lower side effects on the patients, and having safer autonomous navigation for vehicles on the ground, space, or in the sea, at the sea, and also more accurate and reliable imaging and mapping of underground environments, and also sensing of gravitational changes and tectonic shifts, which are very important to avoid disasters like earthquake. So the sensors are really important and playing an important role in many different application areas. However, if we look into the landscape, you can see that still US and UK are having a large share, and Europe is not really strong there. I just want to highlight also that when we talk about quantum sensing and metrology companies, we are looking for two. The first one are developing quantum sensors, and the second one that are utilize quantum sensors for a specific sector solutions. So both these kind of startups are eligible for this challenge. So as I mentioned, quantum sensing and metrology is underrepresented in the European ecosystem, and it is an important field that can really give a leading position to Europe if we move fast. So the specific objective of this challenge for this part is to have developed quantum sensing components to function in real harsh environment for various applications. For instance, for ecotoxicology, pharmaceuticals, biomedicals, space, corrosion detection in mines or power plants, raw material detection, medical imaging, automotive, and many more. The third part that this part of the challenge is focusing on is quantum communication devices. As you know, quantum communication takes advantage of the laws of quantum physics to protect data, and it includes quantum key distribution, quantum repeater, quantum teleportation, and quantum internet. And of course, it has many applications in relation to data protection that is used for the governance, for defense. Space communication is an important part of it, cybersecurity, banking and financing, and other topics. And it's a very important topic, and this is also very strategically important for Europe. And if we look into the landscape, actually Europe has an outstanding number of quantum communication startups, and also European Commission has this initiative called European Quantum Communication Infrastructure, which is where very important goal of the European Commission, where they work all together with all 27 members, and also the European Space Agency, to design and develop and deploy this infrastructure. That can be that is relying on fiber communication network, linking strategic size and national and cross-border level space segments based on satellites and so on. So this is a big program, and quantum communication startups can play a key role in achieving this goal and succeeding in this. So therefore, we have this specific objective identified for quantum communication devices that can be deployed in real environments. So as I mentioned, there are so many achievements already, but mainly they are in lab scale. So we would like them to be applied in real environments, such as quantum repeaters or devices for quantum-based encryption. So by that, I finished the part that is related to the quantum technology components, and I would like to shift to the part B of this challenge, which focuses on semiconductor chip development. As you know, semiconductors play a key role in our modern life. They are in everything that we do or we touch these days. Our smartphones, cars are full of sensors, medical devices, anything that we use with the data and computer and some kind of smartness, and also a lot in our transportation. And the recent chip shortage had a severe impact on key industrial sectors, and it exposed Europe's dependency on the supply from other regions. And this kind of dependency and reliance on import jeopardized European industrial production and also affects European sovereignty. So this is very important to have a very dedicated act together to improve the situation for Europe. If we look at the share of Europe in the global market, we can see that Europe only owns 10% of the market. It's despite the fact that it's a very strategic asset in key emerging industrial areas like mobility, Internet of Things, cloud, space, defense, and so on. Still, we are really lacking behind, and we only own 10% of the market. This is why in this challenge, we are trying to focus on semiconductor chip design to improve and help the European semiconductor industry. And why do we focus on semiconductor chip design? Well, the semiconductor value chain is very complex, but the overall chip design is the stage with the highest value added. Because fabless companies that focus on chip design and invest the highest of their revenues to create intellectual properties, they generate long-term income. Also, designing chips, because it involves high tools and IP licensing costs, long development cycles, and very steep production expectations, it really needs a lot of help and support. It really needs a lot of capital from the beginning to go to the next stage. Just to give you a little bit more depth about what is happening now in the European ecosystem of semiconductors with a focus on the chip design, There are only few companies worldwide that can design and manufacture the most advanced chips at the leading node size. Because there are the skills and the largest investments that are required for this design are R&D, scale up, and IP are really rare. And also the demand for chips in some major markets segments like artificial intelligence, machine learning, and Internet of Things is really surging, and it's coming to it needs a lot of focus to improve. And then because of the lack of the big tech financing for long-term investment in high-risk, high-tech ventures, the startups in Europe are struggling to get funding to scale up, and then they will fall over into this valley of death. So just to have an overview, as you can see, the market for design represents nearly 1/3 of the market of semiconductor value chain, and fabless companies have grown very fast, 2.7 times in 10 years, and now they have 30% of the market. And large system companies engage in design to capture value by verticalization. However, in Europe, the design capacity, mostly with IDMs, has no fabless European company in the 40th top. So Europe is really lacking behind in there. Also, the share of European fabless declined in the last 10 years from 4 to 1%. And because of what I explained in the slide before, the high entry scaling barrier and the limit of funding, there is this valley of death that some of these startups ending up there. And also there is limited skills on advanced nodes in Europe, and there is low level of engagement by system companies in chip design. So this is an important topic to focus on to help the European semiconductor ecosystem. And this is why this challenge is aiming to support expansion of design capabilities and the growth of fabless startups and SMEs in Europe. And it's very critical for the resilience and sovereignty of the European Union. And it will promote Europe's chip design ecosystem to be a cost-efficient way to climb the semiconductor value chain. Because we don't need to create fabs and fundraise, and we just focus on the design. This can be like a fast track to climb on the semiconductor value chain. So the specific objectives of this challenge is to support the design and development of innovative semiconductor components and intellectual properties of analog and digital integrated circuits and systems, including memory, logic, optical components, and sensors. In relevant application areas, for instance, in artificial intelligence, edge computing, Internet of Things, environmental sustainability, health and wellness, 5G, 6G communication, cybersecurity, autonomous vehicles, and so on. Also, the scope includes innovative design approach that address combination of different functionalities, such as computing, RF, power memory, sensing, and so on. Another point that I would like to highlight here is that proposals on software development for semiconductor chip design will also be considered in this challenge. Because 70% of the softwares that are used for chip designs are currently owned by US, and Europe, again, is lacking behind. And also, the proposing entities should really demonstrate groundbreaking innovation in the respective application fields with high potential commercial deployment that it will put Europe industry in the front line. For instance, automotives or industry automation, information and communication, healthcare, aerospace, security, and energy. And the last part that I want to talk about is actually outcomes that is expected from this part of the challenge and the mid to long-term impact that we are looking for. We are looking for the development of semiconductor chip design ecosystem in Europe while increasing the number of innovative fabless startups and semiconductor IP companies in the European Union, which will contribute to the 2030 digital compass of the Union, where it's looking for doubling EU's production of advanced sustainable chips and Europe's digital autonomy. By that, I would like to thank you. I guess we are going to the Q&A session. I invite my colleague Christina Boto as well to join me, who is a project officer in an accelerator unit. So I start reading the questions and I answer the ones that are more related to me, and please, Christina, catch up on something that is, you see, more suitable for you. So how would a proposal be categorized if it overlaps between both of these challenges, semiconductor challenge with quantum tech challenge? If you mean it's categorized for the financial aspect, I don't think there is any problem on that. As long as your proposal addresses one or both, because anyways in the CHIPS Act we also have quantum chip, and these topics, it's a valid proposal. So there is no problem for categorization. How do you ensure, see the growth, how do you plan to ensure 30% for each topic under go, no-go ratings? Do you plan to organize a separate panel in each part of the challenge? I will say something, but Christina, if you would like to talk, follow up on that. I would say when the topics come, of course, if the proposal has a big weight on quantum, it will go to quantum, and a big weight on semiconductor chip design, it will go there. So I don't see any confusion here, but please, Christina, would you like to add something?
Yeah, so the specific modalities of the evaluation have not still been determined. Also, it depends on the number of proposals we receive for every challenge when we will build the panels. But what we can say that there will be specific experts dealing with the specific challenges. So still, we cannot ensure if one panel will cover one part of the challenge of both. This will be depend on the number of applications.
Thank you. Are semiconductor new materials or advanced substrates such as compound semiconductor or epi-wafer design out of scope? Well, the scope of this challenge, as I explained vastly, is on semiconductor chip design. We have another challenge, but that is in Pathfinder, that is called responsible electronics, that is focusing more on sustainable type of materials for semiconductor. I would say yes, this is out of scope because we are focusing on chip design. How do you see the growth of the number and the size of startups in China? Which, well, which exactly will be underestimated because it's actually very difficult to have real data. Because now if I check for instance startups in China and quantum, you see like 13, which is not high for such a large country, because I think many of the research that is happening is funded by governments and we don't have access to a lot of information there. Must our IP already be protected when applying for accelerator, or can we submit patents at a later stage? Christina?
Well, a research on freedom to operate is requested. You have to ensure that what you intend to conduct, you have the rights to do that. So it doesn't mean that you already have patents submitted, but there is that freedom to operate research.
Thank you. Can the EIC support projects to get access to fab infrastructure? I'm Fraunhofer Leti to build demonstrators. Well, this is one of the topics that we are working on, and as you may know, is part of also the CHIPS Act to facilitate this access to the RTOs in Europe. So I can say that we are working on that, and also by the adoption of the CHIPS Act, this will be even more facilitated. Would development of algorithms focus on control of fault-tolerant qubits be eligible as well? If it's something really innovative and it's improving the control system, yes. Is the EIC Accelerator semiconductor chip design open for optoelectronics, namely laser diodes for quantum applications? This is very specific. Because I don't want to favor anything to give more explanation. I just again say that this is focusing on chips design at the applications that we mentioned. So quantum is one of the areas of application. So just please make your assessment based on that. Is the semiconductor challenge also open for companies developing innovative materials for substrate? I answered that before. No. How does the creation of more fabless companies help the semiconductor supply chain problem faced in Europe and globally? Well, basically, this is a part of this challenge that we are facing. As you might know, under the CHIPS Act, there is one pillar that's really focusing on creating new and developing new foundries in Europe. That is a separate story. But at the same time, as I explained, the ownership of design and the design of these chips can bring a lot of revenue without needing any facilities. I mean, you need, of course, the software, but this is why we think this is very important to push forward the role of Europe in the semiconductor ecosystem and the chain, the value chain, because it is at the end of the day, it will bring a certain, of course, let's say budget value for Europe, because there will be, it's kind of a long-term, let's say long-term income for companies in Europe. This is one very positive thing. And the other thing is, so many there are so many opportunities now for this field, because there are very few companies that can do that globally. So there is a big impact. Can you confirm that your organization can apply for the quantum? No. So I will give the floor to Christina.
Well, yes, for the moment, they can apply for grant-only support.
For Accelerator as well?
Yes, only grant-only support.
Okay. Avoiding double financing, how can one ensure that the proposal we're applying does not overlap with the other applications in the previous rounds?
I can take that one.
Yeah.
So if you mean that you have currently a project ongoing within the EIC and you want to reapply, so this is possible under certain conditions. Double financing meaning that you are financing twice the same activity. So it is possible to reapply in case you have, for example, received grant-only support and you want to apply for equity, for example, to a market deployment. So here it will have to see whether you intend to fund additional activities, then it wouldn't be double financing.
Thank you.
If this is what the question was meaning.
Uncensored challenge, 2.5 million grant, can a large portion of the budget be used for pay to European fab for tape out, or fab budget falls from equity? I don't know if this is something that we have to decide, or the project will decide by itself, no?
Of course, I mean, the investment is intended to invest or to finance the market deployment, but it can also be used for, let's say, innovation activities. So if the access to the fab is also considered under the innovation activities, and you need larger amount that cannot be covered by the grant, of course, you can use the equity for this.
Thank you. Are there any quotas for proposals per country to ensure equal funding distribution?
No, this is an excellence program, so there is no quotas per country.
How is an SME defined to be able to submit a proposal, max number of employees, etc.?
Yes, so it's a turnover plus number of employees, but better to use. There is a guide on, I think, on the EIC website where it's the official definition of the Commission on what it's an SME. So, and in any case, when you will apply, you will have to fill in an SME self-assessment. So it's a wizard. You enter 3 basic information to get an outcome of whether you are defined as an SME or not.
Thank you. In chip design, is it okay to have a customer outside Europe, or at least interested customers? Christina, I don't know if there is any limitations for when they apply. I don't think so.
No, not really a requisite whatsoever. I mean, in principle, your market, if your market is Europe, it's already, I think, a good market. So I don't think that's a requisite.
Yeah. Thank you. How about startup working on software for simulation and inverse design of quantum materials? So this entangled from manufacturing. The focus of this challenge is not on quantum software or simulation. We had this Pathfinder challenge last year that we focused more on software and simulation for quantum. What I understand here is that you are creating a software for simulation and design of the quantum material, which by itself is a very interesting topic. If you think this new material can improve the quantum computers, or I mean, this software can help improving the quantum computers and the other components, sensing and communication, you can give it a shot. For the 2.5 million grants, are equipment eligible for costs?
Yes, it is eligible under certain conditions, but in principle, yes.
Thank you. If the application is out of scope of the challenge, will it automatically be evaluated in the open call, or is just rejected?
It will be transferred to the open call. So maybe it's also replies to some of the questions people are asking, whether their topic really fits into the challenge or not. So it will be moved to the open call. Or in case of doubt, you can always apply to the open call, which gather any other topic which doesn't fall strictly under the challenge topic.
Thank you. At chip design, does that also include design of emitter? Like this is very specific question. Anything that is improving chip design, I'm sorry for my voice, it's eligible. Who defines if the proposal is within the scope of the challenge? Only evaluators or also PM? The PMs don't have any access or any right to say a go or no go to the proposal. The proposals directly goes to the external evaluators, and they have access to the work program and a little bit more explanations from the PMs, and they will judge it. Thanks a lot. I don't know if there are any more questions or...
Go ahead.
Okay, if there are no more questions, then I think we can wrap up this session. Anne-Marie, would you like to say some words, or shall we just close it?
No, I just want to say thank you very much for your attention, for all the questions that you had. I hope it will help you to understand what is in the scope and what is not in the scope of this challenge. If you have specific questions on, later when you're working on your proposal, please contact your national contact point. They will be able to answer it. They are also usually listening to these challenges. They are also in contact with us if they would have questions which they, if they cannot answer your question, they will contact Samira to get the answer. So please, I really hope to see many of your good proposals soon. And thank you for your attention.
Thanks a lot, Anne-Marie. Thanks a lot again from my side for your attention. And I also hope to see a lot of proposals from your side. And again, please don't be shy to contact your national contact points to get more help. Thanks a lot.